Now let's talk about some properties of ether molecules. This first few examples that we'll look at are really related to the properties within the structure and how that explains this different in boiling points. So I have three molecule names written here. We have ethane, dimethyl ether, and ethanol. And each one has a pretty different boiling point, pretty significant change between these three. Let's draw these three molecules and then we'll think about intermolecular forces and then be able to explain these differences in boiling points. So ethane, pretty simple molecule here. 2 carbon atoms, single bond between the carbons. Dimethyl ether, this is an ether, so we have oxygen. And then dimethyl, we have 2 methyl groups bonded to that oxygen. And then lastly, we have ethanol, so 2 carbon atoms and an OH, an alcohol group. So all three of these molecules have 2 carbon atoms. Dimethyl ether and ethanol have an oxygen. And the difference in boiling point can be explained through intermolecular forces. So if we look at ethane, we don't have any polar bonds and we don't have capability of hydrogen bonding. Remember, hydrogen bonding is when a hydrogen is bonded to an oxygen, nitrogen, or fluorine, then that molecule can hydrogen bond. So ethane, no polarity, no hydrogen bonding capabilities. The strongest intermolecular force that ethane can exhibit between other ethane molecules is London dispersion forces. And these are the weakest intermolecular forces. And remember, if you have a strong intermolecular force, the molecules in the liquid phase are strongly attracted to each other through that intermolecular force, so a force between molecules. And so more energy is required to separate those molecules and bring them into the gas phase. So stronger intermolecular forces, we have a higher boiling point. And we see that trend with these molecules. So if we look at dimethyl ether, it has a polar bond between carbon and oxygen. So in this case, we have dipole-dipole as the strongest intermolecular force between dimethyl ether molecules. And dipole-dipole forces are stronger than London dispersion forces, and that's why dimethyl ether has a higher boiling point than ethane. And then if we look to ethanol, we have hydrogen bonding. These are the strongest intermolecular forces, and so that's why ethanol has a higher boiling point than dimethyl ether, which has dipole-dipole forces, and ethane, which has London dispersion forces. So stronger intermolecular force. We have a higher boiling point. Now let's look at 2 ether molecules. So we'll compare now dimethyl ether. Which we have above. We said it has dipole-dipole forces. All ethers have dipole-dipole forces. So dimethyl ether, I'll just rewrite its boiling point is negative 24 degrees Celsius. So this means it is a gas at room temperature because its boiling point is lower than room temperature. And then if we compare that to diethyl ether, its boiling point is 35 degrees Celsius, and that's above room temperature. So drawing out these molecules, they are ethers, so we have oxygen bonded to two carbon chains for dimethyl ether. Both of those chains are methyls. For diethyl ether, both of them are ethyl groups. So here's a condensed Lewis structure. Here's the skeletal structure for the same two molecules right underneath. Diethyl ether is a common lab solvent. You've probably seen this in your lab. It's also often called just ether because it's very common ether that's used, but it is diethyl ether. This is a common lab solvent because its boiling point is above room temperature, so it's a liquid at room temperature. And it's a polar aprotic solvent. It's polar because it has a polar bond. We have polar carbon to carbon bond. That's why we have dipole-dipole forces. And it's aprotic because we don't have a hydrogen bonded to an electronegative element. So now let's think about, we have the same type of intermolecular forces within dimethyl ether and diethyl ether, but diethyl ether has a much higher boiling point. This is a result of really two factors. One is that because the molecule diethyl ether has longer carbon chains, although it's only longer by one carbon on either side, that still has an effect on the strength of London dispersion forces. So diethyl ether has stronger London dispersion forces because there is a longer chain in diethyl ether as compared to dimethyl ether. Molecular weight also influences boiling point. So overall, diethyl ether has a higher molecular weight because of the two extra carbon groups. So that also influences its boiling point. So we'll say stronger LDF for London dispersion forces, and then higher molecular weight. And that's why diethyl ether has a higher boiling point than dimethyl ether. If we looked at dipropyl ether, now I don't have the boiling point information on me right now, but you can imagine this would have an even higher boiling point than diethyl ether, because again, we have even stronger London dispersion forces because of the longer carbon chain, and we have an even higher molecular weight because of the longer carbon chain, more atoms in the molecule.